Let's talk comparing box plots. Guidelines for comparing box plots. We want to compare the respective medians to compare location. We want to compare the IQR to compare dispersion or spread. We want to look at the overall spread. This is another aspect of dispersion. Look for signs of skewness. If the data do not appear to be symmetric, does each batch show the same kind of symmetry? And then look for potential outliers. When comparing box plots, it is imperative that both box plots are plotted on the same number line. This is the only way that you can compare all the things that are listed above here, okay? So I'm going to show you how to construct two box plots on the same number line for two different data sets. So data set number 1 is going to be IB morning exams, and I labeled those AM, and then I put in test scores for IB afternoon exams. Those are labeled PM, and I'm going to draw a box and whisker plot for each set. But since I have two lists and I have to get a whole bunch of information about each set simultaneously, I'm going to do two variable statistics to save myself some time. So I'm going to go to menu 6, 1, 2. So my X list is AM, my Y list is PM. I'm going to write that on my paper. What? Oh no, they don't match in dimensions. Oh, that's fine. Okay, then I'll just do it individually. That works too. Okay, so I'll do one variable stats for AM. Sure. Okay, so one variable stats for AM. So I've got min. Let me make myself a little thing here, right? So I've got min, max. This will be AM, PM. I've got min, max, Q1, Q3, and then the median. Okay, so my min is 32, my median is 74.5, my Q1 is 56, my Q3 is 82.5, then my max is 99. Dang. Okay, let's do the same thing for the PM kids. Okay, PM kids. All right, my min is going to be 25.5. Q1 is going to be 78. I've always preferred taking a test in the morning. Median is 81. My brain just turns into mayonnaise as the day goes on. Okay, Q3 is 89. And then my max is 98. All right, cool. So I got my 5-number summary for each one. Now I got to kind of consider what scale I'm going to use. So it looks like the lowest is PM min, and that's 25.5. Then the highest is AM max, and that's 99. So I got to go from 20 to 100. Let's do that. I'm going to count by fives, so I'm not here for eternity. Oops. 65. Come on. Erase that. Oh no. Oh my gosh. All right. 90, 95, 100. Okay, so let's do AM on top. AM, their min is... I'm just going to work piece by piece here. Okay, their min is 32. Okay, their Q1 is 56. Their median is 74.5. Their Q3 is 82.5. All right, I'm just going to make the box now so I don't mess it up. And then the max is 99. Who got it? This is AM. And then PM, hello. PM is going to be 25.5. Q1 is 78. Wow, you can really see when you put these together, like, how much different it is. 81, and then Q3 is 89. And then the max is 98. Look at that. That's a huge difference, right? This box plot is really cool for showing all the different spread, right? Look how much higher concentrated the 75% of the data is on this guy, right? It's just very cool to compare these two things on here. Are there any questions? There are. It says state which examination has the greatest spread for the middle 50% of the data. The AM is significantly more spread out. Look at the size of the IQR. This is why we do it on the same set of scale, right? Look at the size of the IQR for the AM versus the PM. Describe what your answer to part B tells you about the range in performance from the two exams. So it means that like there's a bigger difference between the 25% and the 75% of the scores, right? There's a bigger difference in this guy's lower 25% versus this guy's lower 25%, right? The lower 25% for the PM is much larger than the lower 25% for the AM. Cool. Oh, I don't think I showed you this yet. Okay, so if I wanted to like visually make a box plot, this is going to be the box plot for AM. I'm going to add the variable down here, AM. And then I'm going to go to menu, plot properties, plot type. There we go, box plot. And then it'll just give me a nice little box plot. And I can compare, oh, does it look like mine? Kind of. I mean, I counted by 5, so mine's a little more spread out, but yeah. And then you could do the same thing for PM if you wanted. PM. I'm going to do PM. I'm going to change it to PM. I'm going to add nope, I don't want AM. I want PM. There we go. Then I'm going to do menu, plot type, box plot. Boom. Oh my gosh, he's so much more like spread where he's all concentrated up top. All right, cool. Example 11. A random sample of 9 adults were selected to see whether sleeping well affected their reaction times to a visual stimulus. Ooh, this is like testing how well people can drive after they sleep or not. The first measurement for reaction time was taken on a morning after the adult had slept well. So the first reaction time is the white one, and this is slept well. So this one is slept well first reaction time. Okay. The second measurement was taken on a morning after the same adult had not slept well. Wait, let's keep it not slept well. This is on the second measurement. Okay. The box and whisker diagrams for the reaction times measured in seconds are shown below. Okay, so let's consider the box and whisker diagrams representing the reaction times after sleeping well. So I'm looking at the white one. State the median reaction time after sleeping well. So the median for the white one is going to be, oh gosh, what are they counting on? Counting by here. Okay, so I've got 2.68. Okay, so 0.26, that's 0.28. So it looks like the median for the white box plot is going to be 0.28. All right. Verify that the measurement of 0.46 seconds is not an outlier. Okay, so we're still talking about the same. I feel like this was a confusing wording. That we're still talking about the white box plot because they're talking about like this one, and then they're kind of like going to it afterwards. So we're still looking at the white box plot, and we want to verify that 0.4 seconds is not an outlier. So 0.46 is going to be somewhere up here. So that means we're going to be doing the upper bound test. So that's Q3 plus 1.5 times the IQR. Let's look at all of our inputs. We need the Q3, which is going to be right here. Oh goodness, what's Q3? Let's approximate. It looks like Q3 is going to be 0.35. Yeah, because this would be 3.2, 3.4, 3.5. Okay, so it would be 0.35 plus 1.5 times. And then the IQR is going to be 0.35 minus, what's Q1? Q1 is going to be right here, so he's going to be 0.27. All right, so let's calculate that. All right, now I get 0.47. Okay, so 0.47 is my outlier cutoff. I can't spell that. It's my pen. It won't erase it. Okay, let's just go with it. We know I'm trying to say cut off. There we go. Cut off. Okay. We want to verify that 0.46 seconds is not an outlier. Okay, so 0.46 is less than 0.47. Therefore, 0.46 is not an outlier. Cool. Cool. C. Statewide, it appears that the mean reaction time is greater than the median reaction time. Ooh, this is like asking you about your kind of knowledge of stats, right? So it looks like on the white one, it looks like the median is closer to the lower quartile and it's positively skewed. Also, the range of reaction times below the median is smaller than the range of reaction times above the median, right? So like this is smaller in size than, say, this. So you could have like two different answers for that, right? You could say the median is closer to the lower quartile, or you could say Q1, and is positively skewed. Or you could say the range of reaction times below the mean is smaller than the range of reaction times above the median. Oh, I meant to say median here. I'm sorry, below the median. We can't see the mean on the graph. We can only interpolate what it could mean. Okay, now D. Now consider the two box and whisker diagrams. Okay, let's scroll up and look at them. Okay, considering. Comment on whether these box and whisker diagrams provide any evidence that might suggest that not sleeping well causes an increase in reaction time. Just initial vibes, right? I see that the median reaction time is much higher when subjects haven't slept well. It's almost equal to the upper quartile reaction after sleeping well. Look at this. It's like significantly larger or longer. The reaction time is longer. So that's probably what I would say. I would say the median reaction time is much higher when subjects haven't slept well. It's equal to, what was it equal to? It's equal to, oh my goodness, it's equal to the upper quartile reaction after sleeping well. To the entire upper quartile, or Q3 reaction after sleeping well. That's crazy. Okay. Have a great day.